Hi, this is Mrs. Guntherman. I'm going to work on solving problem 3 in a slightly different method than Mrs. Beglinger did to show you a different approach if you can use whichever one works best for you. In this problem, we have p squared m, and this quantity is to the negative fourth power, and then we have pm to the sixth, p to the second. I am going to deal with the quantity that's raised to a power by distributing the negative 4 to each term within the parentheses. And I'm not going to worry about simplifying anything right off the bat. So I'm going to say p to the second, and when I distributed this is times negative 4, and then m, since there is no exponent, it's implied to be a 1, and that's also times negative 4. And I'm just going to copy down what we had, p m to the sixth, p to the second. I'm going to do the multiplication quickly. P and 2 times negative 4 is negative 8. 1 times negative 4 is negative 4. And then we have p, this would be to the first power, m to the sixth, p to the second. Now using our rules, what we can do is we can combine like terms, and since we're multiplying these, we will add the exponents. So we have p, and p. I'm just going to rewrite these. I'll show the additional steps. So it's p to the negative 8th plus 1 plus 2. And then I'll look at the m's. M to the negative 4 plus 6. When we do the math, we end up with p. This is negative 8 plus 1 is negative 7 plus 2 is negative 5. And then negative 4 plus 2, we have m to the second power, basically 6 minus 4. We don't like to leave these with a negative exponent, so I'm going to rewrite this with m to the second, and then the negative exponent basically means we can put this in the denominator and make the exponent positive. So it's m to the second, p to the fifth, which is the same answer we get using the other method, but just looking at distributing and then working through the problem instead.